As you may recall, pre-written software do not always answer the requirements and needs of all organizations and people. This results in the need for creating customized software that can address the specific problems and issues of organizations and individuals. Wherever there is change or the potential for new opportunities, there may be a need for customized software. Examples of typical application areas for such needs are a finance manager wishing to further reduce billing errors accruing from the use of pre-written software, in company mergers or acquisitions where a new system needs to be developed to handle the IT requirements of both the firms, a production manager wants to further improve the quality and details of product information, a school wishing to develop an online information access system for the students. The process of developing customized software is intricate and complex, and because it is so user-specific, the development time and effort is more. Any software project begins with the process of system study, followed by analysis, and then system design of the most appropriate solution. In fact, any problem area seeking a solution is first handled by these three processes, and then using computers may only be one of the probable solution routes. Hence, all system studies do not necessarily lead to a computerized software solution. Some studies lead to revamping existing systems or reorganization of people or reallocation of funds and resources. Only where the investment in a computerized system is seen to be beneficial in the long term does a system study lead to programming methods and the creation of a customized software solution. Problems or conflicts arise when there is a change in an organization. These changes may occur due to factors that can be categorized into three areas. Technological factors. The application of new technologies accounts for many changes in an organization. Since the scope of scientific inquiry is so vast and the speed of applying new technologies is very quick. Social and economic factors. These arise out of the technological factors and relate to the people and economic issues. Individuals may be reorganized into groups, and the new groups may compete for economic resources with established units. Closed room decisions and operating pressures. This is where the top brass of the organization may discuss the adoption of new methods of operation or the introduction of a new product or revamp existing methods to bring about better quality and efficiency in the system. Irrespective of where and how organizational change occurs, it creates opportunities or problems that managers and other people must cope with. And in coping with the change, people commonly look for new or modified information to support the decisions they must make. A system study is a step-by-step procedure used to identify the problem, then develop and acquire the solution methods needed to control the processing of specific applications. If the answer lies in adopting computers, the solution method is necessarily customized software. Software developers have identified 6 steps that people generally follow to acquire customized software. These 6 steps are problem definition, system analysis, system design, program analysis, program preparation, software implementation and maintenance. The system analysis and design process includes the first 3 steps, while the last 3 steps are included in the programming process. Perhaps the most important step in a system study is problem definition. One must first conclude that a problem exists, and then one must be able to identify the exact nature of the problem before a solution can be found. It is not very easy to prepare a clear and accurate problem definition, particularly when it can be misinterpreted by people with different backgrounds. However, it is the foundation for all the system study steps that follow and hence must be created. There are various steps through which one can survey a problem to arrive at an accurate problem definition. The first step may be to conduct a problem definition survey, which is a preliminary survey conducted to identify the problem or need. One can identify three important prerequisite principles at this stage. The survey has support at the highest level. Irrespective of the level at which the change is requested, the system study must be supported by the top management to make the change effective. The survey team consists of highly respectable people. The surveyors must be a mixed team of people representing all kinds of people. Those who will be the end users, those that are familiar with the existing system, and those that will ensure that the study includes data that lies within the scope of integrity and system security. The scope and objective of the survey are clearly stated. The nature of operations to be surveyed, the divisions or departments involved, as well as the objectives behind conducting the study should be clearly spelled out so that the surveying team knows exactly what to look for. Typically, the problem definition team also holds preliminary sessions called requirements sessions with those who are likely to be affected by the change. This helps people most familiar with current system functions to actively participate in defining specific system goals. The next step after problem definition is prototyping. This is the process of creating, developing and refining a working model of the current operational system. The problem definition stage may have a preliminary prototype model for reference. The final survey aimed at defining the need refines the prototype model by. This refining process may involve the use of personal computers and prototyping software to create a series of screen displays for effective presentation. The result of the problem definition survey and prototyping results in the creation of a system study charter. This written charter, which bears approval of the top management and coordinating committee, should include the following. The system study charter forms the basis of the next step, that is, the phase of system analysis. Most new systems are usually based to some extent on existing procedures. Hence, the first step of system analysis is to gather data on current operations. Much of the preliminary facts may already have been gathered during the problem definition phase, but more details are collected and analyzed to determine the strengths and weaknesses of current procedures. While the kind of data to be collected may vary from one procedure to another, the study team must concentrate on following aspects of the current operations. As you can see, the input to output sequence is often reversed during system analysis. This is because the analysts need an early understanding of current output before they can clearly separate and analyze the relevant processing and input functions. Study teams use a combination of the following data gathering tools: organization charts and organization standards to identify the specific profile and hierarchical positions of people and departments who are likely to be affected by the change. System flow charts, which are diagrammatic charts that trace the flow of data in the current setup from the originating source to the output report. Data flow diagrams, or DFDs, which are graphic aids that help to draw and define inputs, processes, and outputs in the current system. Questionnaires and special purpose forms, that are the printed forms of standard applicable questions to capture data on current details such as frequencies, time utilization, volume and nature of input and output. Interviews and observations, which include one-to-one question and answer sessions, personal observations, as well as simulated walkthroughs to understand the input-process-output procedure. The entire focus of the data gathering stage is on learning what was being done till date and what are the strengths and weaknesses of the existing procedures. At the time of analysis, the focus shifts to learning why the system operated the way it did. Typically, the study team concentrates on three areas while analyzing the current system. Any or a combination of the following tools and techniques may be used for this analysis. A checklist of questions that allow the team to analyze answers dealing with procedural, personal, organizational, and economic considerations. System flowchart or data flow diagram analysis that allows the team to scrutinize and locate essential data and files. Forms analysis that provide details of input processing output forms, documents and processing logic. These are also helpful in identifying key data items and in uncovering those items that are captured, processed and stored but rarely used. Grid charts that can be drawn and used to show the relationship between system input and output. The top-down analysis methodology that allows the study of large systems in manageable parts. Here, the whole system is divided into a main process with related smaller component processes. Irrespective of what methods or tools are used, the culmination of the system analysis stage is the written observation. This comprises a documentation package and an analysis report of the analyst's findings. The documentation package typically includes copies of all forms, charts, questionnaires, input-output documents, and written procedural descriptions that have been gathered and analyzed. The analysis report comprises: these written material are evaluated by the top management and coordinating committee, who may decide to revise the study goals, cancel the project, postpone development till later, or proceed to the system design phase. The system design stage is the first step towards considering the alternative solution methods to bring about the change. During this stage, the designer's goal should be to produce an efficient and effective system, which basically means it must be economical, relevant and useful. This calls for the design team to perform 3 jobs. There are certain issues of methodology and the use of resources that system designers must consider before opting for a design alternative. These can be studied under the following areas. Long-range plans. In organizations that have created conceptual models or long-range plans for the evolution of their information systems, the designers need to consider alternatives that will conform to this overall model. System flexibility. Designers must also consider how adaptable the new system needs to be to changing circumstances. In relatively stable industries where organizations have set patterns, the system need not lay as much stress on flexibility. Whereas a firm in a dynamic industry is vulnerable to frequent changes due to consumer demands and competition pressures, and hence requires a flexible system. Control provisions. Designers need to maintain a delicate balance in creating a system with adequate controls to check the integrity and security of data and ensure that they do not end up developing something that is over-controlled, slow and expensive to operate. Human factors. There are certain human factors that cannot be ignored by the designers, such as simplicity and ease of use of the proposed alternative, its relevance in reducing chores and producing useful information. Create or purchase. System designers usually end up making a choice between creating a new custom-made design or buying pre-written packaged software that will satisfy the need. Economic feasibility. Finally, the economic feasibility of the proposed alternative is the crux or basis on which the whole system development effort rests. Once a detailed study has been made of the available economic resources, designers can decide between opting for an expensive online system or a less expensive system that allows periodic updation. As you can see, there are so many factors that affect the design process that it is impossible to establish an exact set of rules to follow in selecting design alternatives. However, the following tools and techniques are amongst those used during system design. Organization standards, where pre-designed manuals that define the layout and forms of input and output formats and processing logic are used to design the new system. Special charts and forms. The documentation package contents of the system report showing exactly what the current system formats look like are used to create new formats. Top-down design methodology. A hierarchical subdivision of the whole system's functions down to the smallest functional component, complete with its own set of input, process, output functions, is made to simplify the understanding of the proposed system. Design reviews and walkthroughs. Periodic reviews of the design progress, including simulated design walkthroughs to capture errors or contradictions at the design stage itself. Working prototype. An enhancement of the prototype model of the design stage is made into a detailed working prototype to exhibit the proposed system functions. The working prototype ensures that one is not heading towards developing a system that does not satisfy the user's need, or that the time to train users in the operations of the new system is not colossal. System design workstations. The use of a dedicated PC with system design software to develop accurate system specifications in very little time and within the limits of design conventions. The culmination of all the design efforts and methods is a written copy of the system specifications of the proposed design alternatives that conform to the system study goals. The system specification should cover the following heading. Just as there are no fixed guidelines by which one suggests various design alternatives, there are no fixed parameters by which a specific alternative is selected. With the detailed system specifications for the various design alternatives, the team has to decide on the alternative that it thinks is the best possible solution. While the team may propose the best alternative, the top-level management makes the final decision. Hence, the job of the team members rests on making a detailed design report that weighs all the parameters and makes recommendations for the proposed choice. Ideally, the design report should cover the following. It is at the end of this stage that the decision is made to adopt the proposed alternative, or to review the scope, or to address the problem by changing systems under existing resources and parameters. If the final decision is in favor of a customized system, the project enters the programming stage, wherein programming analysis, program preparation, and software implementation and maintenance will follow.